Start at the beginning. So I take a hard drive. I don't know its state. I don't know anything that's wrong with it. And I take it from the client and I plug it into the Deepspar and I start imaging. Well, it may take 3 weeks for it to copy. So I don't make all my settings at the beginning for the things that I would do at the end. Does that make sense?
Customers at this time can take 3 months.
Right.
Or how do you communicate that? I've seen this $300 guy, and in one of these videos he's saying it took him 6 months. How do you explain that to the client?
Slow is better than no. That's the answer. I'm not kidding. That's the answer. If a client calls you and says, I need my stuff tomorrow, and you're like, listen, this is a bad drive. Your answer, if your answer is tomorrow, is no. Do you want it to go slow and get what you got, or do you want the answer to be no? Because you can't make it go faster. Most of the time, you cannot make it go faster. Let's start over.
Let me just, I'm sorry,
Okay.
I'm a little bit out of it again.
Okay.
I think what you're saying is the very first thing you're doing is you're making the image.
Correct.
You're basically taking the information that's on the source drive and putting it on the destination drive. So at that point, while you're doing that, you don't really care how big the destination drive is.
Correct.
Because you're just can only copy, let's say 100 megabytes or 100 gigabytes. You're going to copy 100 gigabytes.
That's correct.
Prior to you taking that destination drive and then making a copy for the client, then you set the destination drive equal, the LBA equal to the source, so that you don't give them more than what. Okay, I got it.
Correct. Because when I plug that into the Windows system, it will then see that this drive is 100 gigs. And when you plug it into the Windows system, and if you're looking at it and it's a random weird number, let's say it's 40 gigs, but you knew the source drive was 100 gigs and you're not getting all the data you expect, that means you did not reset your HPA. So you just take it back to the Deepspar and reset the HPA. That's all you would do.
And then when you're copying it with the Windows system, what are you doing? You have another good drive in there, and you're just...
So we'll talk about all the processes, but I have a server in my office that's 24 terabytes. And I try not to store things locally on machines in case something happens to those machines. So I normally dump stuff to a RAID 6 24 terabyte server. But you may not have that option, so you may just be using individual drives and dumping them to that. The whole point is having multiple copies, because you may lose that too. There's still a chance that one of your drives goes bad or something bad happens in your process. It does happen. So if you have a good clone, and I made a clone of this and it's on this 320, now I take it over to a Windows system and I extract the logical data. I give that data to the client somehow. I have another hard drive plugged in, I put it on my server, I tell the client it's done, do you want it? He says yes. I don't want to lose it before I give it to him, right? So I keep my 320 that I made the image from with it all the time till the job is done, because that's my backup. So, right. So I bind those two together. They travel together everywhere they go. And so it's our drive, so it'll be labeled with our stuff on it, and it'll have our name on it. And the client drive will have the client's name on it. Then the logical data that I copied might be on an external hard drive he provided. I'm copying the data to that. So the other hard drive will just sit with it, not plugged in, the whole time. It'll travel with it wherever it goes for getting that data off. And at the very end, even when I'm done and I have to box it up and mail it to him, I keep that drive together. I keep them on the shelf and I don't use it for 2 weeks. So that way, if something happens in the shipment and FedEx gets hit and his hard drive is laying in the road somewhere, you won't get paid if he doesn't get it.
Are they normally supplying you with the drive that you wind up making the final copy?
I give them whatever options that they want. So if they want to send a laptop and they have enough space on the laptop and they want me to make a directory and dump it on the laptop, I'll do that. It's quicker if I just take an external hard drive, plug it in, copy the data to them. They can provide that external hard drive, or if they don't want to, I'll sell them one. I mean, my office is right next to Office Depot. We just pick up drives daily. That's it. So if they want to buy one, I upcharge it $20 just so that I have enough to pay Allison to go to the store and pick stuff up, and that's it. And I call that service. So that's service because there's a tax issue, and that's a whole nother issue. But physically, at least, that's what you're doing is you're, you know, I make my money. I make $800. That's what I make. I make $800 every time I touch a drive, and I make $50 evaluation fee. That's it. The rest of the stuff is all just passed on to the client. So that way there's no changes in prices. Anything else happens, it's not wishy-washy. It's always the same. Unless I'm making a forensics image, then it's $1,200. It's exactly the same over and over and over again.
Do they require a time frame to be done within a certain amount of time?
Well, sometimes they want it to be, but that's your question. Just because they want it to be, you know, like you can have an expedite fee, but that doesn't make it copy faster. So the expedite fee only says I moved you from the end of the line to the beginning of the line, right? That's it. There's nothing else you can do. If it takes 2 hours to copy that drive, it takes 2 hours to copy that drive. Your downside is that there's a couple things you can do quicker, and I'll explain those as we're going through it today and tomorrow. But you know, you're making judgment calls. Like for instance, can I do a single file instead of the whole hard drive? Is that possible? Yes, that's possible. We haven't covered that yet, but it is possible for me to say, where's the file, find the file, go get the file, and only that file, and no other file, and just image that. And I'll do that to make it faster. So if somebody calls me and says, here's a hard drive, and I need payroll tomorrow at noon, and I'll pay you $1,000 extra money to go get this. I'm like, alrighty then. They never say that. They never give me extra money. They say it, but they never give it to me. I'm just going to tell you, this never happened. They never give you no money. Like they'll send you a bottle of wine or something, but they don't give you an extra grand. But yes, if I can do that, I will only get their payroll file and then send it to them. That's it. And that has come up occasionally in a 24-hour period of time, so they'll pay the expedite fee, and then I'll get that file off and email it to them. So,
by experience, though, do you know approximately how long it takes based on the size of the drive that they have, so that you can say, well, I know realistically that even if I put it at the front of the line, it's still going to take me X amount of hours or days to do it?
The real answer is no. You don't know what's wrong with the drive, and different drives copy at different speeds depending on the problem that there is. If once I hook it up and I know it's only a couple of bad sectors, then I can tell you pretty quickly. But if it turns out that it's like it's having read problems and there's a head problem, maybe I can get a good portion of it. Sometimes I can't get the whole thing, so I've got to rebuild the head assembly. Now I've got a whole nother thing where I've got to order a donor drive, get it in. So the answer is no. Nothing. I mean, as Rudolph said a few minutes ago, you got situations where it's 6 months. Some of those drives are 6 months long. And there are certain conditions with certain Seagate drives that they don't copy fast no matter what you do, and that you're stuck with however speed. But that speed is better than nothing. So if it's JPEGs and pictures and stuff like that, they'll usually wait. If it's payroll, they won't wait. And so you'll know if you can't get it right away, and you can't have it by noon tomorrow, they're going to have to rekey it anyway, then you're actually done. There's really nothing else you can do. If you're not going to be able to do it without a donor drive, what's the point? It doesn't matter if you ended next week. You can ask the client, but they're probably not going to want it. They'll be past that. Does that make sense? So there's a lot of that from that standpoint. All right. So you're good on the end of the job, right? Right before I take off this from the Deepspar is when I do my final settings. And my final settings, you can do them at the beginning if you want, whatever works best for you. But I'm going to tell you from experience, it works better at the end because you don't doubt when you did it. Like I'm going to pick this hard drive up and I'm going to come over to the Windows system and I'm going to work on it at that moment. So I make my settings at the end. So my settings are this. Set maximum equal with source. The next thing I do is wipe unprocessed sectors. And what that means is this. Any sectors I didn't copy might contain data from the previous copy. So erase them because I didn't copy them. You clear? So the whole point is just any sector, no matter what. If these 120, 250, whatever it is over here in the corner, if I did not get those sectors, when I say wipe unprocessed sectors, it will wipe those sectors. All the ones I did not copy, all the ones that are not green, it will erase at the end of my job. That way I'm not wasting time at the beginning of my job erasing drives that I'm going to copy data over. Now, if you're doing forensics, you might want to sanitize all of your jobs ahead of time, but in data recovery, I'm not wasting that time. In forensics, I waste that time, but I already have them pre-done. I have them done ahead of time before I have cases coming in. I've already prepared them. Does that make sense? So that's the next command I do. And then most of the time I do, and I usually hit this last one, which is called activate or deactivate the MBR. Now, let me explain this. I want to make sure it's very clear to everybody. So, we're going to get into some logical stuff real quick. I'm going to show you something. So, I'm in the hex view. So, remember there's 1, 2, and 3. So, there's 3 different maps you can look at. Okay? So, number 1 was the big map that comes up by default. Number 2 is hex. I prefer this. I like to look here because this tells me the truth. Now, if any of you spent time in forensics, you spent time looking at hard drives, you spent time looking at things for a while, you get used to seeing a handful of things that you always know should be there, and they should always be right. At the beginning of your MBR, you should generally see this 3, right? This 3 is the beginning, and this is the data that it would normally look like for your MBR for a boot sector. So I'm going to hit F3 is a view. That's what that's called, view. At the beginning of almost every hard drive, not every hard drive, but at the beginning of every hard drive, we almost always have an MBR. Even when you're in Mac OS, and you're in Linux, and you're in Windows, and you're in GPT, the GUID partition structure, there is an MBR. If I'm in GPT, or I'm in a non-bootable, like if I take an external hard drive and I format it, the beginning of the drive, the first sector is still an MBR, it will still have a signature in it. Everybody understand what I'm saying? Even if I make no partition, there is still a signature. So I'm going to scroll down so you can see this. This one is a bootable drive, right? You guys understand this so far, right? On the bootable drive, as you scroll down on your first sector, you'll see this. Invalid partition table, blah, blah, blah. If you've looked at hard drives all the way back to 1982, you basically have this in the beginning of your drive, always, right? If it's bootable. If it is not bootable, then there is no bootstrap. Then the top part of this is empty. It's blank, right? But you always have, at the end of the sector, 55AA. That is the partition signature. That's what it's called. It's partition signature. It lets Windows or Mac or any system know. Now Macs can ignore it, Linux can ignore it, but it's still there. Still in the beginning of the drive. There is a MBR, 55AA says it's okay to mount me. I'm initialized. Okay? No? Nobody? Yes? Everybody's good with this, right? Even if I have no partitions and I have nothing else, 55AA will still be there. 55AA does this. Now, I'm going to turn this machine off. I'm turning off the Deepspar because I'm going to take off the destination drive, the one I wrote to, right? That's where I'm looking at this on. I'm not really looking at it on the source drive. The source drive wrote it to the destination drive, and I'm only seeing what's on the destination drive. Everybody comfortable so far? So I'm turning it off. I'm going to take off my destination drive. So this is the drive I just wrote all that data to. And I'm going to hook it up to a Windows machine. And I'm going to show you what things look like on the drive and how you can tell stuff right away without wasting any other time. So on Windows, you have a disk management tool, right? You've seen this before. Everybody, I hope, in this class has seen this. If you have not seen this, it's okay. But, right? If you've ever formatted a drive, ever looked at a drive, maybe I should say disk management is the requirement for the class. But no. So on this list right here, have you guys ever plugged in a hard drive, or you've ever seen like a dynamic RAID array or anything that you've plugged in from another drive, from another system? There'll be a red circle right here. You ever seen the red circle? There'll be a red circle and it'll say foreign entity or uninitialized. Have you ever seen that? So that right there, the box, I'll show you. So now I'm going to plug in this hard drive so you can see. Okay, now this is the 320 gig, right? Did I set an HPA? Can you look at this and tell me if I have an HPA?
You do.
Do I?
No.
Doesn't look like it.
I did not set the HPA. I did not hit that button that I told you to hit before you disconnect it from the Deepspar.
And the reason being is because it says right there 200 and something.
Correct. I have 100 gigs in the beginning and 200 gigs here. It's a 320 gig drive or so, and after it's formatted, it's only about, I don't know, 203 or something, whatever it is. It's 303 or something. You lose 7 gigs for every 100 when it's formatted. So it's 7 gigs for every 100. 7% of your drive to formatting. So so I'd lose 14 to 17 gigs or whatever it is. So 21 gigs. So 100, 200, it's not, otherwise it would be, you would only see the partition, right? You would only see it would end here at the partition. So I have a partition that is defined in my system that was on the original hard drive. That means I copied the first sector. I copied the MBR. The MBR has the partition in it, right? So watch this. So it doesn't matter what tool I do. How many of you have looked at anything in hex? You've at least used a hex editor once in your life. Yes? Yes? Have you? Never? Okay. Have you used RStudios? You have RStudios?
I don't have it. I just looked at it now.
Okay, there's a hex view also in Reclaim Me Pro. So there's a way you can look at your drive and right-click on it and see it in hex. You can download a hex editor for free. There's hex editors. I'm going to use RStudios because it's a $79 package and it has a hex editor in it, and it's just cheap and easy. I have tons of tools that I can use: Xways, WinHex, anything else. But I'm going to start up RStudios. RStudios is a data recovery package, does multiple file systems and everything, but I don't really care. I'm just going to use the hex editor. So here's my drive right here. You can see it over here in the corner. Okay, now you see it's 300 gigs, so this is my drive. I'm going to right click on the drive and I'm going to open the hex editor, view edit. That's how you open it. So now this is now my hex editor. Now this will look just like it did on the Deepspar 5 seconds ago. We looked at the first sector, right? So I hit F3 and I did a view in hex. Now I'm actually looking at the drive on a Windows system in hex, so I can see the same thing. Everybody get where I'm going with this? I know I'm introducing a lot of things all at once, but it's a barrage of stuff and then it comes back to get you. It'll all come together. Everybody happy? Alright, so this is the same exact thing. Now if you scroll down a little bit, sometimes it's hard to always tell in some of these tools where the beginning and end of a sector is. You see down here, this is the end of the sector. So this is sector 0, and here's the end of sector 1. You see 55AA, right? Everybody good so far? So this part means I'm bootable, so I get a 3, blah, blah, blah. You can see invalid partition, so up to here is good. Now, how many partitions can I have by default in an MBR system? Master boot record. 4. Can only have 4, right? So coincidentally, the amount of space that's down here at the bottom for 4 records, and I'm not going to sit here and point out every single location, sector, and jumps. There's classes that do that. If you want to do, where's the jump, look at the 8th sector, look at where it goes. There's classes that do that. I'm not going to spend time on that. That's a week-long class by itself. All I care about is this. If you come to the end, do you see a 55AA? If you do, at least you have an MBR. That means you're at least on the first drive. In a RAID array, it will also be the first drive. it will also have a 55AA. In the first one of the first partition, it will begin with 55AA, because this part right here at the back is the partition structure in the end. All right, you can have 4 records. The first record begins right here. So this is the beginning of the first record, and then it loops over to here. It's done in 32-bit encoding. So the way that a record works is you have a pointer to the beginning of a partition in 32 bits. Then it has the size of the partition in 32 bits. How large of a partition can you have in 32 bits? What's your biggest partition?
So
32 bits counts to like 4 billion and change. Divide by 2 for sectors. So you have about 2.1, 2.2 terabytes. That's the largest partition you can have in a 32-bit file system is 2 terabytes. Right? Everybody good? So FAT32, 2 terabytes. In TFS, it'd be 2 terabytes in 32-bit partitioning, which is all MBRs. So we have a new one called GPT. Have you heard of GPT? GUID partition table. That's to get past the 2 terabyte problem. All MBRs were limited to the 2 terabyte problem because you cannot even address it. Even if I bought a 4 terabyte hard drive, I cannot address the last 2 terabytes because I can only count in 32 bits. So just keep that in mind. We'll talk more about that tomorrow. So we'll go through that again. Yeah. Yeah? No? Good? All right, so now the next thing is this. If you're looking at this partition structure, my eyes immediately always go to the third set of bytes right here. In file systems, when you formatted your hard drive, do you remember that there's this table of 99, it had 99 entities, and the 99 entities define what type of partition you created. When you were using FDisk or you're formatting something or using Linux, it has a chart and there's 99 items, and you can say what type of file system do I want. Each one has a different name. Like if you're in Linux, a swap file is 82, right? So you'll have a number that will go with that partition. This is all old school. This is stuff for 30 years. It's been around in your partition types. And most of you have seen it, you just don't realize. You remember all of these things. Now there's a lot on this screen, but let's say if you were looking, usually it's just going to give you one screen and it'll usually just say here's your partition types. So these are all your containers for the types of partitions. And see if I can find a image. That we can see. They all defined the partition screens right here. Everybody's seen one of these, right? When you would go to partition your drive, and then it would ask you over here, and you could select what type you wanted. I want FAT32, I want NTFS, I want whatever. There's only 99. It's a fixed number for 2 bytes. It's 99, 0 to 99. And so if it was a swap file or a Linux partition or whatever else, that's what it would be. So you would usually have a specific number. And usually on a DOS screen or something, this format, this number over here, it would usually have just been like one screen in FDisk. I really need to save one of these. Disk. There was a second one off of DOS when you were formatting your disk, and there was another screen. It would ask you what type of partition type did you want, and there was 99. Okay, everybody understand what I'm talking about? Anybody remember it? It's all Linux at this point because nobody does it in DOS. There we go. This. You guys remember seeing this? Every time you went to go format one, this was the list it gave you. No? Am I the only one old enough to do this? You remember formatting in F-disk?
Yeah, I do, but I really don't remember the list.
Because nobody ever selected any of these things. They always selected, so 7 is HPFS, which was OS2, NTFS, Windows, and then now it's exFAT, but exFAT has its own whole nother delimiter that goes in that category. And then the other one was always FAT16, so these were your FAT16s. And then now you only ever see, like you don't see any of these other types anymore. Now you only see your Linux swap files as 82. So those are typically the ones that you're going to see. So anyway, so this is where those 99 types come from. So if you look at this chart right away, you'll know that 7 is NTFS. Right? Everybody happy there so far? So now we're back over to here. This is where that number is. So when you have partition structures, and you're almost always going to see an NTFS structure, because 93% of the market is Windows. If it was a Dell, in Dell's utility partition, they make a special partition, and it says DE. So right underneath or right above here, there would be DE, and then there'd be your partition, which would be 07. So you know it came from a Dell if it said DE. So there's a bunch of those that are predefined from that standpoint. So I'm immediately looking to say NTFS. I have a partition right away, I know it's NTFS, no matter what the system says. Everybody good? So I'm looking at 2 things. Or 3. If you say I look at 3 to make sure it's boot partition, 7 to know NTFS, 55AA to know that it is a actual partition structure Windows can mount. Okay?
You can see there whether it's bootable or not as well, right?
Yeah, there's an active flag in here,
0B.
but if that would be the active partition, but this was originally a boot drive. But yeah, it's where is it? 003, is that what you
I
said?
think it's that's 0B.
Oh, right there.
Yeah.
Yep. There's an active flag partition, and so when you set it, that's what it'll say, that this is the active partition. Otherwise, you could say it on any of the partition structures. All right, so now let me show you what happens. So this is what it looks like. You can always look at this everywhere, all the time. RAID arrays, anything. Get used to seeing this. So I'm gonna unplug this. I'm getting rid of this drive. Everybody happy? I'm getting rid of it. Now I'm going to go back to the Deepspar. I know it seems a little convoluted. Everything will just kind of come together. You'll kind of, all of a sudden, you'll just start understanding what those items all are as they go together. I've been doing this a long time. Usually tomorrow, everybody will get it. They'll spend all day reassembling drives, and then they'll... Come on, come on, come on, come on. So we're just taking a step back in time. I only stopped long enough to show you a couple of things. I'm going back to the Deepspar and back to our original drive. We're in the original setup. I haven't made any changes. Everybody's happy so far, right? All right, watch this. I'm going to start up my original drive. I'm going to get back to the state that I was in. I'm back in here. I'm back to my destination menu. Come on, come on. I'm back to my destination menu, okay? Now, like I said, normally what would happen is I would do 3 things. I would say set LBAs equal to the source. I would wipe unprocessed sectors. I'm not going to do those at the moment for a time constraint. I'm going to do this last one. Activate or deactivate the MBR. Okay? So the MBR itself, if I activate or deactivate, what this is going to do, I'm going to come down here and say deactivate. It's going to change 55AA to 55BB. Why would I do that? Anybody have any idea why I do that? What happens when I make 55AA anything else? Doesn't matter what I made it. What?
Bootable and non-bootable?
So the active flag he was talking about earlier, where we were at the OB, that's the one that's the active flag for whether or not it's bootable or not bootable. In all Windows systems, and Windows DOS being the first in the PC world, then followed by technically current Mac OS really isn't current Mac OS, that's really Unix, and so you're really talking Linux was actually second, and then following that would be Mac OS, because that's a BSD derivative. The first versions of Mac were not the same as this. So for 20 years we've been on a new version of Mac OS. So since '99 or so. So everybody okay with this concept so far? I know you don't know what it is now, but if I take 55AA and I change it to anything else, all DOS and Windows systems forever have always expected there to be a 55AA, or it is not a recognized system, right? So I changed it. I'm turning this off again. We're going back. That's all it did. That's all it did. Did nothing else. Now watch what happens when I plug this hard drive in disk management. Watch what will happen. So when you buy a brand new hard drive and you plugged it into your system, this is what it looked like. Remember? Every time, if you were in disk management, when you plugged in your hard drive, this is what it would look like. Because it's not formatted, right? So as far as Windows is concerned, 55AA means it's already formatted and initialized. What does this red circle mean? Yep, means not initialized. So this now is how you initialize it. And if I initialize it, I will overwrite the first sector. It will kill my partition structure and the boot record. So it only kills the first sector, but it's not a good thing to do, right? And if you have this open, like you saw when I opened it, it mounted and you could see it right away, right? But what happens if I don't? If I didn't have that open and then I mounted disk management, if I do this normally afterwards, like and I haven't opened it, the box pops up. You've seen it before, right? The box that says this drive is uninitialized. Do you want to initialize it? And if people are too happy, hit enter. It reinitializes the drive that they just had data on. Right? Yes, everybody's happy with that, right? So now this drive says not initialized. If you go look at the data now, so I'm going to do exactly the same thing we did a minute ago. I'm going to go into RStudios. You'll see RStudios doesn't care. It still knows it's exactly the same drive. It has a partition name, Francisco Pelamonte. It has 100 gigs. The partition structure's still there, right? If I go look at it in a hex editor, the only character that changed, the only one that changed is right here, BB. So Deepspar knows BB and AA, and it will activate and deactivate. If you cannot mount the partition, Windows can't change it. It can't. When you first plug in a hard drive and it has 55AA, Windows will try to mount the partition and the little box will pop up and spin around and it'll change your dates and times and it'll change everything. This is a poor man's write blocker. It write blocks Windows from being able to make changes to it, in the sense that it won't mount it and it won't change dates and times. It won't do the journaling. It won't mount NTFS. It won't say raw. It won't say, it won't do any of those things because it doesn't see it as initialized. This is a poor man's write blocker. All of your tools will work fine. You see RStudios right here knows it's fine. Same thing over here. Let's say I go use another free tool. Let's say I use FTK Imager. FTK Imager is a free tool. A lot of data recovery people use it as well, not just. I can still see all of this content. So I can still see 55ABB, blah, blah, blah. I can still see hex. It's still there. There's still a partition. None of my data is gone. Everybody understand? So my whole point is all I've done is protect it from Windows. Now think about this. I made an image. I've got 1,000 bad sectors. When Windows starts crawling through your directory structure and you first plug it in, what can happen to your machine? What sometimes happens when you have partial file systems or partial things are corrupt?
You need to format this device.
What happens to Windows sometimes?
Freezes.
Or
Crashes.
crashes, blue screens. You've seen it happen before, right? You've plugged in a hard drive, Windows is blue screened. Right? That's happened to everybody here, right? I sure hope it has, because it happens all the time. If you have a corrupt file system, has something corrupt on it, Windows can blue screen when you plug in the hard drive, like seconds after you plug it in. You see it pop up, it goes bloop, and then goes blue screen. And then what happens when it reboots? What's the next thing it does? What's the first thing that happens after Windows blue screens and it reboots? None of you have seen this happen. The next thing it does is on the blue screen, it'll say, I see that last time I booted, it did not boot safely. I'm going to run ScanDisk now, right? And then it starts going through 3 phases of running ScanDisk. And it eats your files. It'll eat anything that is not complete. And there's a reason for it. I'll show you in hex what actually happens. It's actually horrible. It is doing terrible things to your drive. And you have just made an image. You have a drive that doesn't work. And you made an image onto another drive. If Windows blue screens and eats your data, you may never get that data back again. So if you don't reset that so that Windows doesn't see it, I've seen this happen before. You plug in the hard drive, you start up RStudios, you start up a tool, you start carving data. You go to lunch, you come back, it's in the middle of eating your data. Have you not seen this before? Have you guys not gone to lunch and come back and all of a sudden it blue screen and it's eating your data? Checked your disk while you were gone? It was working fine when you left, but it's not working fine now. So you want to protect the data that you're working on also. Keep this in mind, it's really important. You will eat your data. So,
Even from Windows, maybe.
yes.
I thought that's a repair function. You want to check
Okay, right.
what's repairing.
For the sake of time today, I won't go into it, but tomorrow I will explain what the repair function is. I'll go in depth in the repair function, and you will cringe, and you will feel pain and anger and all these things about what the repair function is, because the repair function is only to delete your data. That's its job. It's called the transactional file system. The entire point is whatever you did last time didn't complete, so let's erase it. That's what it does. It will eat your data. I'll show you exactly how it works, because the first 2 phases are only checking 2 bytes. And the third phase basically does a bad block test to see whether or not your drive is bad. So if you had your original drive, it would actually eat your whole drive. So it would actually be in the process of marking everything bad. Alright, so anyway, so this is the point. This is all I'm trying to say at this point, is that you need to get used to seeing this screen. This is what's going to happen from here on out. And so also, did I set the HPA? Can you tell? I have a 300 gig drive. I have 300 gigs available. So I did not set the HPA. And in RStudios, when I first started RStudios up, if it sees a partition structure, so it knew 07, so it knew NTFS and it knew 07 in the partition structure, you'll see it knows it's 100 gigs. So I still have not set the HPA on this process. So you can tell immediately when you come into a system, let's say you hire a tech, the very first mistake they always make is this one. If you hire somebody who works for you, they'll either always forget to reset it, so your HPA will be set too low, or your HPA will be set too high, or all this raw space will be available, and they'll make a mistake and give the porn back to the wrong guy. Understand? Super critical to make sure you always check this. I want my HPA to be set here. And the reason is this. If I process this partition, I'm okay. But when it's corrupt enough that there's no partition information, it thinks it's the whole disk. So I could process just the partition and be fine, and it would leave the unallocated empty space alone. But there's a lot of times that that's not the case, and that's not what happens. And it processes the entire disk. Okay? Everybody? Okay. All right. Let's go back. So there's one other caveat with the space that's available. Remember I told you that Deepspar has Windows tools? And the Windows tools can read that whole map file that it created at the end of the disk. If you set the HPA, it can't see it. You understand that, right? If I set the HPA, then it's only the logical space that was available on the original disk. And those sectors are outside the end of the disk. So if I needed to use the Deepspar's tools on Windows, I have to not have an HPA.
You're talking about when you originally started it up, how it wrote the passport information to the end. That's what you're saying, it won't be seen?
Correct. There is some other information that you can use there that we haven't gotten to that's data functions. And there are a couple of instances that I mentioned, like for instance, I mentioned I could be surgical and I could say, let me find this file and only get this file. Well, in order to do that, the Deepspar has to be able to see that information at the end of the disk. So if I knew that's what I was doing, because remember, I'm also not really done with the job because I haven't imaged anything, so that's why I don't set my HPA earlier on. I set my HPA at the very end when I'm finally done, but if I'm going to go work on a Windows machine with that little configuration file, then I do not set the HPA at that point. That's why I'm clearing that HPA and making sure there isn't one. If I had an HPA, there'd be a red box right here and it would say HPA is set. And that would be a bad thing if I thought I was going to go work on the Windows tool. Is this clear to everybody why I'm talking about this? So if I work on the Windows tool, I can realign all the sectors and I can say, look at my MFT. Tell me all the files that you have. Pick this one file, the payroll. And then make a change to your map file so that I only image that one. Flag just those sectors. Then I say image, and it goes from the beginning of the disk to the end of the disk, and it only copies the 10 sectors I needed. And then I can extract that one file. In order to do that, it's got to make changes to that map file that's at the end of the disk. Okay? So there are some other ways to do that, but it's not real efficient. Let me show you what I mean by this. All right, so now let's start over logically so far. Exit, pretty straightforward. It will exit the software. Help. Help is really just all your serial numbers and stuff like that. There's no real help. It's it's here's about my disk imager. Here's what I own. Here's what version I have. Blah blah blah. And if you really want help, pick up the phone and call me. Like that's it. That's their help. Okay. Nothing else. View is view the sector. Okay. Now if I have a network card, you can say what's my IP number and stuff like that. View the sector is the useful one. That's where I hit F3. Says it right there, F3, and that's how I can see a sector, right? So I'm on the first sector, right here on the first sector, F3, I can see the whole thing. Same thing, and look, 55BB. Now, the Deepspar on the destination menu will now say activate the MBR because it's BB. So it knows that the Deepspar set that to BB. Okay? We will talk about the data function in a minute. It's more complex than I want to tell you right now, so we'll get to that in a minute. I want to make sure I went over everything anybody had a question about on these Deepspar menus as we're working backwards. So you know the top, you know the HPA. This right here is clear block of LBAs. This is only to reset just a small chunk of whatever you already had green. For some reason, if you read something and it was green and you wanted to reread it, like if I wanted to make a change, I can actually just say reread and make those sectors white. So I'm going to say from 0, make 10 sectors white. Bam. Now, when I image again, it will treat them as original. I had never touched them. Does that make sense? There are some times that you just need to be like, I wish I could clean that one sector up. So they added that menu option. It didn't used to be there. Everybody good?
Like pretending you never touched it.
That's correct. Just a small chunk instead of resetting the whole thing, because it used to only be configuration. Now to reset a handful, you can actually select them. You didn't used to be able to do that at all. The next one is reset configuration, which starts all over as a brand new drive. Technically, I almost never ever do that. You would never really want to just restart, because whatever you've copied is good. You just always want to keep as much as you can. So that's the granular way. This is the full-blown way. Wipe drive sector by sector. That does exactly what it says. Starts at the beginning, zeros all the way to the end.
I was going to ask, I don't know where this fits in anything, but I've been sitting here with this question. When you're going through and you're trying to copy all this data, obviously, like you said before, there's buku numbers of bad sectors on the drive before, even when it's brand new. So you go through and it's reading all this data, except it's reading everything except the bad sectors that it can't read. You don't know if they're bad and they've been bad since the thing was new, or they're bad because of some damage, or they're bad, or if there's data on it and it's just not reading it. You don't really know, correct?
When you first get the drive, even if the bad sectors that were made, that's why we were talking about the ones that were done at manufacturing time, those are removed from your view. Your drive should be completely good as far as you are concerned to write from 0 to the end of the drive. Any bad sectors that previously existed are either removed in the P list, and if they're done while in use, that's where the G list comes from.
Okay, but that still recognizes the G list and the P list then?
Yeah, that stuff is already done by the hardware. So at that point in time, the drive is hiding it from you. So you don't see those sectors.
Okay,
The Deepspar doesn't see those
okay,
sectors.
That was my question.
Right.
I didn't know if it's still...
What happens is when you have data that is not being written, it's like during the write time, when you have data that is writing, then it physically will try to remap that sector if it has the content in memory. Later on, as it ages and that sector goes bad, then the sector, you don't want to kill it. You don't want it to remap. If it does, you haven't read the data because it was corrupt. So it just leaves it bad, which is a good thing for us. So when it says it's a bad sector, we're lucky that it says it's a bad sector, because if the drive just went crazy and just said, oh, mark that one bad, it doesn't have a copy of the data that existed there, so we would have no chance at recovery. And some bugs do that from time to time on certain drives, that they'll just go crazy and start marking the whole drive bad. But so this all happened during the age of the drive. When you started, it was fine. Later on, as you're using it, something bad happened. Somebody dropped it, head hit the platter, it ages poorly, it's 10 years old, and the sector is worn out. You've written to the same sector over and over again 2 million times, things like that. So those are the ones that are going to show up as bad, and that we're trying to reread them and put them someplace else.
And how many of those do you actually get to put them someplace else? In other words, do you wind up where it reads everything's green, or do you still wind up with some...
Well, we're working this entire situation. So every time that you get a drive, it's going to be slightly different. And how you handle it is slightly different. Our goal is to get the lowest number of unread sectors, the lowest number possible. And we can use all of these methods. We can alternate through all of these methods and modify PIO, DMA, LBA 28-bit, ignore ECC. This is a stack of tools, and we are going to go through the entire stack from beginning to end. And that's why that's why it seems so choppy right now. I'm teaching you one at a time, and then at the end, you can use them in combinations with any combination, whatever that combination works best for this drive. And you're going to determine that by doing these small little tests like I've been doing as we're going through. And so I'm trying to get you to a spot where when you first start up, oh good, I'm lucky, I read the first sector. What do I have? No matter what the system tells you, you can hit F3 and go find out. Oh, I know this is NTFS. Can I make some judgment calls based on the fact that it's NTFS? What if it's a Mac? There's different judgment calls that you'll make. We'll get to that when we start talking about software and its layout. But right now, I'm trying to give you the stack of tools to be able to say, from the beginning to the end of the drive, these are the errors that I've had, and each one's different. Every error is a person. It's his own thing. It's his own unique item. And you're going to focus on that one to the best of your ability with the limited amount of tools that you actually have to do. And so we're going to break all those down piece by piece. Does that make sense? But any that say that they're bad are ones that we focus on. They were not done at manufacturing time. You don't see those unless you go get a PC3000. And you don't need it for this. For data recovery, there was never any data written there. You only need to focus on the ones that data was written to. And that's where the difference comes in between allocated and unallocated. As we've talked several times, I just haven't showed it yet. I can divide the world between allocated and unallocated. So forensics people like allocated, which is why I'm addressing all of it, and then data recovery people want, because forensic people want everything, allocated and unallocated. Data recovery people, we only need the allocated. It's rare. We might need it, but sometimes we're stuck with it either way. Does this make sense all the way through? Okay. Back to the menu. Wipe drive sector by sector. This is the destination drive. I'm on the destination drive. It would wipe. This is my clean. This is how I get it clean. If you have the forensics module, you get security erase, which I described to you yesterday, so you now know what that does. Format drive is only if you have the forensics module. There is a way to write an image file. It is worthless. It is not worth doing here. There's 100 other ways you can do it and not use an expensive tool to do it. So my personal opinion, even if you had forensics module, you guys don't use this, right? Because it does it without data recovery functions. So in other words, it's the DD dumps a file to a hard drive. That's it. That's all it does. Does nothing else. It's worthless. Skip it. Don't use it. Write test pattern only if you need to worry about your hard drive is working right or not. You can write a test pattern. Wipe unprocessed sectors, the ones you didn't copy, no matter what. Okay. Wipe sectors by map. So there is a way that you can actually say, I only want these 20 sectors to be wiped, and there is also a special file that you can load that you could tell when it wipes a sector not to make it 0, you can make it whatever you want. But there's a file you have to make and you have to load it. And so basically you could say every sector, instead of writing 0 here, you could write in case didn't get me, in case didn't get me, in case didn't get me. You know, so you can make it say that if you want to make it say that. Get my point? But that's a command line actual item. You have to make a 512 byte sector and make it what you want. And then if you have the forensics module, you can compute the MD5. Again, damaged images, never compute the MD5 the same twice. I'm just going to say. If they're damaged, the chances of you getting the MD5, you really take your destination after you've produced the best image possible, then you make an image of your destination, and then you MD5 that. And then you hand it to the guy and you explain why it is what it is. Because he could not get certain sectors, you're going to have zeros no matter what. Does that make sense? All right, and then activate and deactivate MBR. Remember, I erased those first couple of sectors. So right now there isn't one. If I do F5 again and I go from here, it will now catch those first 10 sectors. So I'm going to get them back. So now I've got those first 10 sectors again. Now it'll be 55AA because that's the source, not the change that I made. Remember, I made a change to the destination drive. I just overwrote that. Is everybody okay with this? All right. Source drive. So now, there is an express diagnostics. It's only, I don't run it all the time because it can cause like ATA command problems and stuff. If you have a problem with a cable or a buffer and you don't know that you're working correctly, you can run it. What it does is, and it probably will knock my drive off, but it'll run like a smart test. It'll run a buffer test to make sure it can transfer data. It'll make sure your cable's okay. That's really what it does. I think, and some people run it all the time, I don't think it's a great plan. I think it affects ATA commands and it causes you to reset your drive all the time. So I leave it off. Media test. Now this is to see if your source drive can read. And there's a very specific reason this exists, and it's not really for this mode. When I hit enter, what's going to happen is this. I'm going to read from the source drive. I'm just going to say, can I read sectors? And if it's green, a head on my hard drive is good. Everybody understand? So I did a media test. It tried for 10,000 milliseconds. How long does Windows try? 600 milliseconds. So if I tried at 10,000, I might read sectors that Windows could not read. Does that make sense? And all it did was check for 120 sectors or so to see if they were good and I could read. If I see green, you do not rip heads out of your drive. Now, do you know which heads I tested? Nope. You do not know in this screen. It's just whatever was the beginning of the drive. It just read a bunch of sectors and it tells you that they're green. You don't know that they're on different heads and you don't know if they're in a different place. There is a specific test and this screen will change. After I run a head allocation test, it will make a list of heads and then it will change and add them. Okay? So I will do that so you can see that right away. I'm going to go to the first menu. The first menu under the imaging items, down at the bottom, it says build a head map. Okay? I can build one, I can clear one. So if I build a head map, when I go back to the media test, I will now have heads. Okay? There will be one more screen that will change. I will show you before I do it. Image process. Remember, I can add or remove steps. You see this blank space down here? It's not just coincidence that it's blank. All of your heads will show up in the list right here, and you can turn them on or turn them off depending on damage. Okay? So I'll build this head test, this head map. So, now this will take a few minutes to build. I'm on a Toshiba. That's the drive I'm on. So I'm going to select Toshiba. And now you'll see down here at the bottom, it's going through and starting to build the zone tables. This is how many sectors are contiguous for each head. So 2 gigs here, 2 gigs here, 2 gigs here, 2 gigs on this platter, 2 gigs on this, and it's dividing them all up by heads. Now it's doing this logically, it's doing this in memory. It's not permanent. None of the changes I make here are permanent. It's temporary just for these settings. And it's saving these settings in that little configuration file. If I take another hard drive and hook it up, it won't have any of these things. Does that make sense to everybody? Those are married together. So it's going through the drive. Now it is not moving the heads. It is only reading this logical table. This is just the percentage that it's taking to read that table. When it's done at the end, like how many heads do I have? I have 4 heads. So this drive has 2 platters, 4 heads. So you can tell right away, that's what I got inside this drive. Without ever opening it, I can tell what I got. So now, when I'm done running this head test, built me a map. Now it knows the heads. Now you'll notice LBA, see the number LBA? To the right, to the left of it, your left, there is now a head number, H0. So if where I'm at is on head 0, as I move through the drive, like for instance I hit the end key and I move to the end of the drive, the very last one is also on head 0. See, now I'm on head 3. So where this cursor is sitting on this sector that hasn't been copied is head 3. So these are all broken up into chunks, and as I go through the drive I can now tell where I'm at on a platter, where I'm at on a head. Not that that matters, it doesn't make that big a difference, but you do care if, let's say, head 3 was damaged. Remember the picture I showed you yesterday? The head was ripped off of the drive. If I did a test now on that drive, there would be one head that would be completely red. There would be nothing. I couldn't read anything at all. And immediately I would go, well, I'm turning that off. I'm going to read everything else and I'm going to turn that off. So I can now do that. I'm going to go to the source drive again. I'm going to go back to the media test. I'm going to hit enter, go, and now you'll see for each head it's actually testing to see whether or not I can read from all the heads. Even if you had one head that was partially red, if you have green, you might want to turn the head off and read all the other platters so that no more damage happens, but that probably means that there's media damage and there's a scratch somewhere on the platter. And if you leave the head on, it's going to keep scratching. And then the platter dust comes off of one side and goes into the other heads and destroys it. But if you turn it off, it won't try to read them. It'll just skip them. So the head will just move right past them. So you could read the other 3 platters. Does that make sense? So the other 3 platters might have the data together.